Hello, Mr. Thompson here with a math video lesson. This one by request. In the comments to a previous video, someone asked if I could cover solving equations using factorizing, also known as factoring in America, in the US, but here in Australia and probably the UK, I would guess, they say factorizing. We say factorizing. So we're going to cover solving equations. Just going to talk about solving equations as a thing. And then talk about factorizing, and then we'll put those two things together to see how we can use factorizing to solve equations. All right, so here we go. Okay, solving equations, what does that mean? Another way that this gets talked about is finding the zeros of an equation. Okay, and the reason it's called that is because we're answering this question. The question of what is the value that makes an equation equal to 0. Okay, so for example, we'll take a really simple example, one that doesn't require factorizing. 2x minus 4. So y equals 2x minus 4. We want to find the value that we can plug into that equation so that the equation equals 0. So what we do is we set the equation equal to 0, and then we can just use algebra to solve it, right? So we get the value of x. We're going to look at what this looks like on a graph. We can graph that line, okay, using the slope or gradient and the y-intercept. And we can see that we can find the place, we can look on the graph for where y equals 0, which is of course, here at the origin, right? Right down there. So if we follow that over to the line, we can see what the x value is at that line, and it's x equals 2. So we've looked at two different ways of solving this, algebraically and graphically, and it comes out the same, of course, which is good. Okay, but I want to look at this in another scenario, another kind of equation, and then that will lead us to why we need to do factorizing for this. Okay, so another kind of equation could be where there's two things being multiplied together. Okay. Now this way that I've written it might look a little bit strange, but if you think about it, one example of equations that take this form are when we have something like, say, x plus 1 times x plus 2, right? We have one thing times another, right? Just like we have one thing times another. A times b, A is kind of the x plus 1, and b is the x plus 2, right? And the important thing that we're going to think about in this case is the idea that anything times 0 is equal to 0. Okay, so what we can do is in an equation like this, like a times b or something times something else, if we do a times 0, then that equals 0. If we do b times 0, then that equals 0, right? So y is equal to 0 anytime that a equals 0 or b equals 0. So there's two ways to make this equation equal to, or there's potentially two ways to make this equation equal to 0. So we can use that idea and apply it to equations like this one with the x plus 1 and x plus 2. If the first part equals 0, then the whole thing equals 0. So we can say, we'll look at this graphically first. Okay, we'll come back to what I was saying. We have our equations like this look like a parabola. They're quadratic equations, and so we can do the same thing where we find where where y equals 0, right? Down here on the x-axis, y equals 0, right? But y also equals 0 on this graph on the other side as well, right? So there's two x values as I've said, there's two x values, two places that can make this equation equal to 0. So applying that to this particular equation, we can take the x plus 1 and set that equal to 0, and we can take the x plus 2 and set that equal to 0 and solve those, and the solutions for each of those two equations gives us an equation where this original one will equal 0, where it crosses the x-axis, where it lines up with 0 on the y-axis, right? Now, the question is, of course, how do we get equations into a form that looks like that, right? With one thing times another, one expression times another expression. And that is where factorizing comes in. So let's look at how to do factorizing, and then we'll come back to this and look at solving it, okay, and actually finish it, because I haven't sort of finished this Most folks might be able to do that on their own, but we'll look at another example and finish that one. So, factorizing. Okay, the concept of factorizing is that we're taking equations that look like this, right? Ax squared plus bx plus c, and remember the a, the b, and the c would be actual numbers, right? For any particular example. And we're going to take it and put it into the form x plus p times x minus q, or those could be pluses or minuses, and again the p's and the q's there would be numbers, right? So it's one thing times another, one expression times another, okay? Now, so let's look at the steps to do that. The first step is that we look at that original equation, the ax squared plus bx plus c, and we're going to find a pair of numbers, and we need that pair of numbers to be such that when you add them together, they equal b, right? And that's the b from the original equation, this coefficient of the x term, right? And then when you take those same two numbers and you multiply them, you get the product of a and c, right? So you need to find a times c, and we need to find numbers that multiply to that number. Okay, so let's look at an example of this. Okay, let's look at the equation y equals 2x squared plus 7x plus 3. Okay, so a in this case is 2, b is 7, and c is 3, right? So we need numbers that are going to add to make 7, which there's an infinite number of pairs of numbers that we can add to 7 because we include negative numbers here. Excuse me. But we need those numbers to multiply to 2 times 3, right? So 2 times 3 is 6. So let's just list the factors of 6, okay? 1, 2, 3, and 6, right? And of course, most people can probably see that 1 and 6 add to 7, okay? Before we move on, I want to note, I only put positive factors, but we could list these all as negative, right? Because negative 1 times negative 6 is positive 6, and negative 2 times negative 3 is positive 3. But those, of course, when we add all negative, pairs of negative numbers, we're going to get a negative. Those would make like negative 7. And in this case, we want positive 7. If this was a minus, then I would want to be using negative numbers, okay? And, factorizing does get more complex. This isn't a lesson on all the different ways to factorize. I could make such a video, but this is mainly just about using factorizing to solve equations. So I'm focusing on that. Okay, so we've got our two numbers, 1 and 6. They add to 7. They multiply to 6, that was the goal. So what do we do now? Well, we rewrite the equation using those numbers rather than the original b term. Okay, so instead of 7x, we're going to use 1x and 6x. Okay, like so. So we'll have 2x squared plus 1x plus 6x. Now, of course, you could just write x, but I'm sort of emphasizing that we're using that 1 and then the plus 3, right? That's our second step, okay? Rewriting it like that, okay? For our third step, we'll go to a new page. And I've underlined this just to emphasize the 1x plus 6x is equal to the 7x, right? I haven't changed the equation, I've just rewritten it, okay? So, next step, we are going to group the first two and the last two terms together and factor out common factors, the greatest, the highest common factor, GFC, HFC, whatever you call it, okay? So y equals 2x squared plus 1x plus 6x plus 3. That was our equation from the last step. And we're going to group the first two and the last two terms. Now, I want to make a note here that 1x plus 6x could have been written as 6x plus 1x because that's the same thing. You can write them either way. Either way would be fine, okay? You can still carry out all the steps and come out with the same result, okay? So we've done that. And we want to factor out our greatest common factor. So in the first, from each of these expressions, so we look at the first group, and the only thing they have in common is the x. So we're going to factor out the x. So we're going to rewrite our equation. It's going to be x and then the quantity 2x plus 1, because those are what's left behind. When we factor out an x from here, we're left with 2x, and then when we factor out the the x, we're just left with 1, right? Same thing on this other side. We want to do factor out the greatest common factor, and the 6 and the 3 both have a factor of 3, so we're going to factor out the 3, and we're left with 2x plus 1 again, which is kind of what we wanted. Okay, we want, because our next step is looking and seeing that we have that same thing in both of these. We have a common term. Okay, so now we actually have a common expression, right? So we're going to factor out that common expression, just like we factored out the x and the 3. We're going to factor out the 2x plus 1. So we're going to take that 2x plus 1 and write it on its own. And we're factoring out that out of this, which leaves us with an x, and we're factoring it out of this, which leaves us with a 3. So we get this next expression, which is just x plus 3. Okay, and now we've done it. We've got our equation written as a product of two expressions. Okay, we've factorized it. We've now finished with the factorizing, the factoring. Okay, so now we can solve that, right? To solve that, we set each of these two expressions equal to 0, and we solve those to get the zeros, the solutions for this equation. So I'll do that this time. I'll do that completely. We get 2x plus 1 equals 0 and x plus 3 equals 0. And using algebra, we would subtract 1 from both sides and then divide both sides by 2. And then we would just subtract 3 from both sides on this one, and we get -1/2 and x equals -3. And those are the numbers. We can check that, and it's actually really important to check your work. So take these two values and plug them into that original equation, the original one that you were given in your problem. Plug it in for x in the two places where the x is, simplify that, and you should get y equals 0. It comes out to 0. Regardless of which of these two numbers you plug in, you will get 0 both times, and that's what you want to do to make sure you've done it correctly. Once again, there's all kinds of other equations. This is just one pretty quick example. If a equals 1, so in this case we had a 2 at the start of our equation. If a equals 1, it's even a little bit easier. You can still go through all the exact same steps. And sometimes there's different signs, pluses and minuses, and some of that can get a little bit tricky. It takes a lot of practice. So get into that, and if you have any specific examples that you'd like, I can do example videos, additional example videos as well. But that's it for now. Thanks for watching. Catch you next time.